This is an algebra video with a focus on quadratic inequalities. So let's have a look at an example of a quadratic inequality and how to solve it. So we would have a question that looks something like this. Solve x squared plus 3x plus 2 is greater than or equal to 0. X is an element of R. So before we begin to work through this, let's just take a moment to have a look at the question and make a couple of observations about it. So obviously here we have a quadratic, and a quadratic is a type of a function. We can graph it. And what this statement really means, x squared plus 3x plus 2 is greater than or equal to 0, is that we are interested in the solution of this quadratic where it is above the x-axis. So there will be a bit of a visual element to our solution of this question. But since we have a quadratic, the first thing that I'm going to do is factorize the quadratic. So pause the video here now and do that yourself, and then check and see if you're correct. So now I have the line x plus 2 times x plus 1 is greater than or equal to 0. There's a big temptation to write down on my next line x is equal to for my solutions, but I have to steer clear of that because I don't have equals to, I have an inequality symbol. So now I must make a decision about what is the correct inequality symbol to use in my solution. To make this decision, I'm going to sketch the quadratic. I don't need to be too fussy about my diagram. It doesn't need to be an exact graph. It just needs to give me an idea of what the quadratic looks like and where its roots are positioned. So I know that this is a U-shaped quadratic because it's a positive x squared, and I know that the results for the roots should be -2 and -1 by looking at what would happen if I let both of these equal to 0. So I'm going to write those two values onto my sketch to represent where that quadratic would pass through the x-axis. And now, since I'm concerned with the part of the quadratic that is above the x-axis because greater than or equal to 0, I'm going to highlight that part in my sketch. My decision about the direction my inequality symbol in my solution should take then is going to be based on the direction that this shaded portion is moving in relation to the root that it's attached to. So what do I mean by this? Well, you'll see here that I've drawn a line down through -2. I want to gauge, is this shaded portion to the left or to the right of that line? So clearly this blue shaded portion is to the left of the line going through -2. So I'm going to use a less than symbol. In fact, in this case, I'm going to use a less than or equal to symbol. The reason that I've got the equals part is because there was an equals part in the symbol in the question. Okay, now looking at the other side of the diagram, I can see that I've shaded this portion here in blue, and I want to think about, is this to the left or to the right of the root -1? So to help myself make that decision, I've just drawn a line down through -1. Okay, so I can clearly see that the shaded portion is to the right of that line. So I'm going to the right of -1. That means I want to use a greater than or equal to symbol for that one. And now my solution is complete. I can say that the quadratic x squared plus 3x plus 2 is above the x-axis. If I move back from -2, that's the less than. And if I move forward from -1, that's the greater than. Let's have a look at a second example. Okay, so I want to solve 2x squared plus 7x plus 3 is less than 0. X is an element of R. So again, I've got a quadratic and I want to know where it's less than 0. And this simply means that I want to figure out where it's below the x-axis. So again, I'll start by factorizing the quadratic. So again, pause the video and take a moment to do this yourself and then check and see if you're correct. So I've got 2x plus 1 by x plus 3 is less than 0. Again, resist the temptation to write down that x equals to -3 or that x equals to -1/2, as you normally would if you were solving a quadratic. We'll use our sketch to write these values down, but in our solution, we want to use our inequality symbols. So I have my sketch again. It's a U-shaped curve again because I've got a positive x squared. And this time, my roots are -3 and -1/2. And just take a moment to think as you're filling those values in, which one will be further to the left on the number line. So obviously -1/2 is closer to 0, -3 is further down, that's why I put that there on the left hand side. So this sketch will now help me to decide what symbols to use for my inequality. So let's just go back for a moment again and think. We're looking at where the quadratic is below the x-axis, so I'm going to highlight this portion of the graph. So I've marked the part of the quadratic that is below the x-axis. And of course, it's below the x-axis between its roots. So now I just need to decide whether I'm on the left-hand side or the right-hand side of each of the roots. So again, sometimes it can make it a little bit easier if you draw a line down through the root to decide whether you're on the left or the right of it. So when I look at the -3, I've drawn a line down through it. I'm obviously to the right of that value. So I can say that x is greater than minus 3. Notice how the symbol that I'm using, the greater than symbol, it almost looks like it's pointing to the right. So again, that may help you to make a decision about which symbol to use there. And going back to look at this negative half then, well, clearly I'm shading to the left of that, so I'm going to use the less than symbol. And again, I'm going to the left, less than looks like it's pointing to the left. Again, that might help you to make a decision if you find that a bit tricky. Now, it's fine to leave your answer like this. X is less than minus a half, x is greater than minus 3. But in this case, you can see that the shaded portion is all one section of the graph between these two values. So in this scenario, I can write my answer in a condensed format to indicate that x is between two values. When doing this, make sure that both your symbols are pointing to the left. And again, make sure that the value that is further to the left in the number line gets put in the first position. Okay, let's have a look at the third example. So here we have the instruction to solve minus x squared plus 4x plus 5 is less than or equal to 0, where x is an element of R. Now, I always find it's a little bit of a nuisance to factorize quadratics that start off with a negative. So I'm going to sort this out to begin with by changing this to a positive, by simply multiplying my entire inequality by -1. Just watch out, because there's a couple of repercussions in my inequality as a result of this. Okay, so what happens when I multiply by -1? Well, obviously the sign of all the terms is going to change, but don't forget there's another kind of implication as well, which is that I must reverse the direction of the symbol. So my inequality symbol now is going to be greater than or equal to. These two quadratics actually have the same roots. It's just that one of them goes through the roots in an N shape and one of them goes through the roots in a U shape. In terms of how this affects my question and my sketch, which will come up shortly, it means that actually I can use either of these two statements for my sketch and my solution. So now I want to factorize the quadratic. Pause the video and do that yourself. So in this case, it's x minus 5 times x plus 1 is greater than or equal to 0. And now I'm going to draw my sketch, and I'm going to draw my sketch based on this adjusted version of the quadratic. Just to point out, you could just as easily do it for the first one. You should get the same result at the end. So I've chosen to go with the positive x squared quadratic, so it'll be a U-shaped curve. Again, resist the temptation to write down x equals 5 and x equals -1. I do not want to use any equal signs because there are no equal signs in this question. Instead, I'll mark my roots into my sketch. My roots in this case are -1 and 5. Since I'm looking at the positive x squared quadratic, I'm looking above the x-axis. So I'm shading that portion of my sketch. I'm drawing a vertical line down through each root to help me decide is it to the left or to the right that I've shaded in relation to each root. And for -1, I've shaded to the left of the root, so it's going to be a less than or equal to symbol. And for my other root 5, I'm shading to the right-hand side of that, so it'll be a greater than or equal to symbol. Notice how I've got two separate parts of my diagram shaded, so I'm not really going to worry about putting this together as one statement in the same way that I did up here. It's perfectly fine to leave them as two separate parts. And just a moment's comparison. Why do you think I have an equals part in my symbols here, but no equals part in my symbols here? It's dictated by the original question. If there's no equals in the symbol that you're given, then there's no equals in the symbol that you use in your solution. And in the same vein, if there is an equals part, then make sure to include one in your solution also. At the end of this question, I'm just going to take a moment to show you how it would have been completely fine to use the negative x squared, the negative quadratic, to do your sketch also. Don't feel, however, that you need to go sketching everything twice. You don't. This is just for illustration purposes only. So if I had decided to go with the negative x squared, it's going to be an N-shaped curve. It still has the same roots, -1 and 5. But if I'm going with the N-shaped curve, I'm looking at less than or equal to 0, so below the x-axis. Notice how, in this scenario, I'm still going to the left of the -1 and to the right of the positive 5. So I'd end up with the exact same solution at the end of my question. Let's have a look at the fourth example. So this time around it says solve x plus 2 squared is less than 16. X is an element of R. So clearly there's an element of tidying up needed to begin this question. I've got a perfect square on the left hand side. Pause the video for a moment and expand that, and just take care not to make any of the usual mistakes. Remember, it's square the first by second by 2, square the last. So now I have x squared plus 4x plus 4 is less than 16. It's starting to look like a quadratic. I do have an issue at the moment. Do you spot what it is? I don't like that 16 on the right-hand side. We know with quadratics we have to have a 0 at the end of our equation or inequality before you can proceed to factorize and find roots. So I'll bring that 16 over to the left-hand side, and then I'll tidy it up into a quadratic, which I'll factorize and solve. And I'd suggest at this point pausing the video, completing this yourself, and then playing and seeing if you're correct. Okay, so I'm tidying it up to x squared plus 4x minus 12 less than 0. I need to factorize this quadratic now. My factors are x plus 6, x minus 2, less than 0. I want to draw a sketch to decide now on what symbol I'm going to use in my solutions. So taking a moment to look at the quadratic that I've ended up dealing with. It's x squared plus 4x minus 12 less than 0. It's a positive x squared, so it's a U-shaped curve. And my roots are minus 6 and 2. Our instruction is to solve for this quadratic less than 0, so I'm looking below the x-axis. So I shade that portion of the graph. And this portion of the graph is to the right of minus 6, so that would be a greater than symbol, and to the left of 2, so that would be a less than symbol. I can leave my answer like this, it's correct, or I can run it together into one statement because it's one shaded area, in which case I'd write minus 6 is less than x is less than 2. If you're wondering, have I gone reversing my symbols here? I haven't really, because just to take a moment to notice, here I've written down x is greater than negative 6. Do you see how the narrow end of the symbol is pointing towards the negative 6? Make that more obvious. Well, in this statement, the narrow end of the inequality symbol is also pointing towards the negative 6. So actually it's the same statement, just reversed. Okay, here's one last example. Example 5. Find the range of values of k for which x squared plus kx plus 4 equals 0 has real roots. Now you might look at this question and go, 1 second, there's no inequality in this, it's an equal 0, so how can this be the same type of question as we saw previously? Well, what you might notice here is the way the question is worded. Find the range of values for which the quadratic has real roots. So now cast your mind back to previous algebra chapters. If I know that a quadratic has real roots, then what statement can I make? Well, you might remember that I can then state that b squared minus 4ac is greater than or equal to 0. So really what I want to do is I want to create that inequality. And then that's what I'm going to be solving. So I'll first of all list a, b and c, and then I'll fill them into the formula. A little bit of a tidy up will give us k squared minus 16 is greater than or equal to 0. Okay, so this is a type of quadratic. What is it? It's a difference of 2 squares. So we're going to factorize that to give us k plus 4 times k minus 4 is greater than or equal to 0. So now we're back to the situation in previous questions where we drew our sketch. So this difference of 2 squares is a positive k squared, so it's a U-shaped curve, and its roots are minus 4 and plus 4. And I want it to be greater than or equal to 0, so in terms of my sketch, I'm looking above the x-axis. So I'm shading that portion of my sketch. And now I want to decide, am I going to the left or the right of each of these roots? Well, I'm going to the left of negative 4. So k is less than or equal to negative 4. And I'm going to the right of 4. So k is greater than or equal to 4. So this is my solution. But let's just stop and think for a second what it actually means in the context of the question. Well, this k value here, it could be anything. But I know that if it's minus 4 or smaller, that this quadratic will have real roots. But equally, if it's positive 4 or bigger, that the quadratic will have real roots in that scenario as well. If I have any value in between those two, between negative 4 and positive 4, then the quadratic would not have real roots.